Okay, very good evening to all of you. Some of you, your friends have written examination, I think. There is an examination today. Some of, okay, however, we shall continue and if any person will be miss this class, they will go through the video. There is no problem. Race condition, one of the very important concepts of operating systems, networks, database management systems, very, very important. Of course, in what do you call logic gates also, it's very, very important. Approximately 4 to 5 different kinds of aspects this particular race condition will be so available. Let us discuss in terms of general method, followed by operating system, followed by networks, and then followed by database management system. I have promised you to discuss all these four. So first of all, let us see basics of this race condition. What exactly this particular race condition will be, and how this race condition will be existed or occurred with the system. Let us see. So race condition is an undesirable condition. It is not expected condition. Always it is not expected condition. It could not be available in our system actually. When it could be gets occurred here in the sense when two or more processes are trying to access same data at the same time or concurrently, or accessing is one aspect. Second aspect is performing some kind of operation. Operation might be, so for example, if you consider banking information system, if you want to share or forward or transfer some amount from your account to some other account, they may be performed from your account, it is being deducted, and your friend's account, it could be added, okay, deposited. Something like is being happening in banking system. Similarly, those are the operations actually. If you are trying to access the data item concurrently, and if you are trying to perform the operation, most performing operations will be reading and writing. So in between reading and writing, you do have some kind of operation. For example, X equal to read X from the database or global area and modify it, and then write on the same to the global area. These are the operations actually. Read, write, in between these two, some modification of that particular global value could be there. So if you perform such kind of operations, then race condition will be gets occurred. Race condition will be gets occurred. Most probable error which is being done or which is being occurred when race condition will be taken into account is, what is the most probable error is, so the updation which was done by one process will be overwritten by other process. Updation will done by one process will be overwritten by another process. Okay, here several number of processes will be gets connected to one CPU. Several number of CPUs have been connected to one memory, loosely coupled or tightly coupled systems. Whatever maybe you can consider. Loosely coupled in the sense, several CPUs have been connected to single memory, so that is called as tightly coupled. And several systems does have its own memory and also connected with some other memory, server's memory, then that is called as loosely coupled. Okay. Tightly coupled in the sense, if main memory, server memory is not available, then your all systems are not supposed to work properly. Whereas loosely coupled, though your system, your server system is not available, you can perform your operations. Something. Let me give you one example how loosely coupled and tightly coupled will be executed. For example, ATM machines. If so-called ATM machines are not working with the bank, so bank has been shut down the server. For example, HDFC Bank, and HDFC Bank has been shut down the server, and all HDFC Bank ATMs are not supposed to work anymore. They could not do any other operation other than withdrawing money. Then such kind of systems are called as tightly coupled. You cannot perform any other operations. They are called as tightly coupled. Loosely coupled in the sense, if the Gmail account is not there with you, no, Gmail server is not working today, right away from morning to evening, then you have to open your laptop and you can perform other operation other than Gmail. Such kind of things are called as so loosely coupled. Okay. So either of the systems, you may be perform some kind of operation concurrently, or you may be access the data at concurrently. With these two situations, race condition will be gets occurred. Let us see one by one. So this output of this operation, either it is data accessed concurrently or the operations accessed concurrently, so that the output will be always taken into consideration how the requisitions have been made by the process on this specific data item. That's very important. The sequence of operations, what kind of sequence of operations could be done by the particular process is very, very, very important while applying this race condition. Let us go ahead. So normally these are associated with operating systems. Of course, not exactly with operating systems and databases and networks also. So these are associated, but most of the cases when people will be listen or heard this word, immediately they will be so striking with the operating system course. Wow, race condition is there with operating system. Okay, because race condition, the word race condition has given in operating system books only. In database management systems, the name will be some other way, and in networks could be some other way. Okay, however. So normally, if you consider race condition in computer memory or computer storage, so computer memory in the sense random access memory, that is RAM. Computer storage in the sense hard disk or any other auxiliary storage devices will be done. Commands to be read some data or write data onto the particular so memory at a larger amount of time, a larger amount of data, not exactly 1 or 2 bytes, some trivial number of bytes, 1 terabyte of data or 2 terabytes of data will be done at the same time. At the same time, in the sense, the same instance of time, then many number of over returns will be get secured. Many number of over returns will be get secured. What does it means? All of previous data will be so rewritten by, I mean, old data will be rewritten by so newer values. So that could be done continuously. Okay. Then, so such kind of operation, race condition will be occurred in your system. There might have several causes. There might have several causes. These causes will be, there is a possibility to have system crash. During system crash, you have read the data. And after system crash, you may be perform the write operation. The write operation cannot be successful. Or otherwise illegal operation. So you have read data, you wanted to read some HDFC's A account data, but you are trying to, I mean, your operation or your actual instruction has been read right from HDFC, so account number 25. So that could not be, so the data which is required by us to perform some kind of operation. That is called as illegal operation. And there might be having some kind of errors while reading some older data, errors while reading some older data, and errors while writing so that particular newer data, updated data. So either of these four causes will be occurred in our system. Then there might have race condition. There might have race condition in our system. Now. So if race condition will be also get occurred when instructions will be gets passed in incorrect mode. Let me show you an example in the next slide, then you could understand what exactly. So look at this. Okay, suppose we'd like to take two processes are there, and one variable is there at global area. These two processes are trying to take that particular value, and whatever the value which is available with that particular variable, that can be just flipped. 0 will be there, it could be converted into 1. 1 will be there, it could be converted into 0. That is the actual operation actually. So performing flipping is one particular operation here. So if you want to perform such kind of operation, so two processes will be there. Let us see. So if a condition will be get circled with race condition, how it could be. Look at this. So process 1 has read the value. This is the value which has been taken by process 1. And process 2 has read the value. Same value can be taken. Okay, same value can be taken. And the process 1 has to flip the data and return onto the main memory. Similarly, process 2 also flip the data or return onto the main memory. Look at this. If process 1 taken 0 and can be flipped will be 1 and can be written onto the memory again 1. Then process 2 will be taken this particular value. This particular value can be taken so by process 1 or process 2 and can be flipped and can be written in the sense your 0. Here it is 0. Flipped and written onto the main memory or global value here in the sense. So 0 can be taken by process 1, it can be flipped by 1, and 1 can be taken by process 2 and it can be flipped by 0. So finally your answer must be 0. But you can see here, so the processes have been operated their operations in a disorder mode. So read value from the memory by process 1. So it doesn't perform flip operation immediately. It could be interleaved by second process for reading same value from the memory. Okay, then immediately interleaving can be happened by process P1 or process 1. Then flipping and written onto the main memory. So 1 has been written. And again interleaving by process P2 or process 2. Then it is being flipped. What is the actual value here? That value is 0. What is the actual value here? It's also 0. 0 can be flipped into 1. 0 can be flipped into 1. So actually, whatever the value which has been written by process 1 has been overwritten. Though it is 1, overwritten will be it's happened. So that is why so the value actually required value is actually 0, but we got 1 here because of so operation has been done in random manner. Where if wanted to eliminate this race condition, how you could operate this one in this way. Normal circumstances, you can see here. So where exactly you have read the value by so process P1 and it has been flipped and it could be written onto the so main memory. After process 1 has done, then process 2 will be taken the value that is 1. It is flipped and it can be written onto the so main memory. What is the expected value you have? That value is there with us without race condition. With race condition, value, unknowing value or non-desired value has been occurred here. So this is the problem with these two. Okay, flipping in the sense not operation will be gets operated on binary data. That is the meaning here. Okay, flipping in the sense not operation, not 0, that is 1, not 1, that is 0, something like that. Now, normally in operating systems, where exactly this rest condition will be get secured? Rest condition will be get secured in critical section problem. Okay, in critical section. Critical section in the sense, while updating your database, you have, for example, you have transferred some amount from your account to your friend's account. During that time, so from your account, on your account, it must be deducted, and to your friend's account, it must be deposited. During operating these two operations on your both accounts, no other transaction will be interleaved. If it is interleaved, obviously values could be changed. Values could be, proper values cannot be so updated into your respective accounts. So that operation, actual operation, which is required to perform in atomic mode, only one operation mode, such kind of so execution is called as a critical section. Such kind of execution is called as a critical section. Okay, so set of instructions which are being executed alone There is no interleaving by some other processes. Alonely they are supposed to execute it. If such kind of set of operations will be there, then so that set of operations will be called as a critical section. So look at this. This critical section is always expected atomic actions. Okay, no other process will be interleaved. If other process will be interleaved, obviously, so whatever the data we have written onto the actual storage area, that will be so in wrong value mode. So that is the basic problem. So to avoid, to reduce this particular kind of thing, so how to do the process here in the sense, so if any one of the processes, for example, so modification will be done by, so this is the actual global area, that is A, and the process 1 will be there, and the process 2 will be there, and the process 3 will be there. So they have been taken the value in the beginning. They have been taken the value, for example, A value is equal to some 25, for example. 25 has been taken. There is no problem. Concurrently, you can take. There is no problem. 25 has been taken by this one also. 25 has been taken by this one also. There is no problem. Reading of data doesn't have any problem. Process P1 has been updated into 30, and she wants to write the data into this particular area back. While writing operation will be done, while updating operation will be done, then remaining all other systems are not supposed to access that particular value. Okay, that value could not be given. Permission has not been given to other processes. So that not giving permission, those set of instructions are called as critical section. Okay, how this could be? Let us see. Critical section will be seen in such a way. So every critical section for problem might have some entry section, and the actual operations which are required for that particular critical section will be there. After execution of this critical section operations, and it will be comes out from the entry section in the sense it must be reserved, or it must be take the permission from operating system. I am going to take the critical section execution. Will you please give any option to me? If acknowledgement will be taken, or acknowledgement will be released by operating system, now my process will be enter into critical section. If acknowledgement cannot be there from the operating system to your process, you will never ever enter into critical section. That is what entry section. Exit section in the sense you have to give the acknowledgement to the operating system that yes, I have completed, and chance will be given to some other people, or another requisitions will be get acknowledged, something like that. Okay, so I'll draw a diagram for you, then you could understand very easily. Okay, then remainder section in the sense after completion of your critical section, any other processes will be there, any other instructions will be there, they will be executed. For example, this could be done. This could be done in terms of so allocating process IDs for two different systems. For example, two different child processes at two different geographical systems. So geographically, my system is at Nasarabad. Some other system is there at Guntur. So both of us have trying to take the PID, process ID. Then situation will be seen like this. Let us see. So process child ID will be equal to 4. I am trying to create the child process for my actual process. And the P1 also perform the same operation at the same time. Same operation at the same time. There is no even petaseconds also not having any gap. Immediately, same time, P1 also perform the same. Then after creation of, after 4 keys being gets operated, first operation will be request for process ID. Process ID is a unique value which is being allocated to every process during allocation by operating system. So P0 is requesting for that, and P2 also, P1 also requesting for that. Next available process ID will be 2615. For example, it could be allocated for P0 child process and P1's child process. Does it possible? Same process ID could be available with two different processes? No, it never happens. It never ever happens. Okay. Yeah, 507. If you want to talk with me, just wait for a while. Where is this? Then at the end, I'll give you some chance to you to ask some questions at this moment. Fork is a system call which is used to create a child process. I hope that this is the question from you, I think. Fork is a system call, operating system call, which is used to create a child process for a parental process. If a child process will be gets created, immediately it is requested to operating system to allot one process ID for my child. So only one process ID is there, then it could be allocated to two different types of systems at the same time, then a race condition will be gets occurred. If any other process, P4, P5, P6, some kind of process will be refer 2615. So at 2615, two different types of process are there, then the problem will be raised. Then the problem will be raises here. So therefore, this kind of scenario is known as the race condition. Okay. It never ever happened, but we have to, for the discussion point of view, I have taken this one, this example here. For discussion point of view, I have taken it never ever happened here, so it could not. Okay. Then in networks, how race condition will be existed. Networks. Soon you have to listen the networks. You have to remember one particular word, that is channel, communication channel. Okay. While two or more users are trying to attempt the communication channel and which is not being allocated, such kind of scenario is called as the race condition. Okay, race condition will be seems like this. So why this race condition? Normally, if you observe, I am using internet. You are also using internet. Many people are using geo internets, and every time people are being communicated with a geo channel only. Then we don't have any. We are not facing any race condition here. If I was allocated, you could not wait for so internet allocation for you. So you are not supposed to wait for that particular internet allocation. Then where exactly the race condition will be existed in networks? Where exactly it is being existed when while doing this kind of operation, there is no notification will be received by the channel, and there is no information received by the either user also. Neither of them has received any information. Okay, so they will be put into hold position, and the why hold position is gets occurred, we don't know. That where exactly this could be occurred here in the sense. Look at this. When a channel might be having very long lag times, very huge amount of lag times. Lag time in the sense, normally if any user is requested for accessing the channel, so immediately one reputation will be made from the user to channel. If it is available, immediately acknowledged. If any other persons, so let us consider. So person A is available here, person B is available here. There is a communication channel. There is a communication channel here. Data is propagated here and there between many number of users. And A is playing a very, very, very huge game, for example. Huge online game, for example, which will be taken some 1 GB of bandwidth, so to play this particular thing. So, okay, 1 GB of bandwidth has been taken, and completely this whole bandwidth is allocated to A. And B is trying to make a requisition REQ, so for the communication channel to access 1 MB of 1 MB of channel from you. So such kind of requisition has been made. Does it available? No. Everything is allocated to A only. When A has been finished, then B will be get the requisition acknowledgement back. Okay, ACK will be get back, and this communication channel will be allocated to B. Unless otherwise, unless otherwise B cannot be get the channel here. If this kind of situation will be there, this situation is called as race condition. Of course, in terms of networks, it is called as congestion. congestion. How the controlling of a congestion will be done? There are many algorithms are there. Using those algorithms, so congestion control will be gets happen. Okay, it is called as congestion. In terms of race condition point of view, whatever the problem you have been faced with the congestion, same here also, race condition also. So in networks, race condition will be, pronounced as condition. In operating systems, it has been pronounced as race condition. That is the only difference. Now, come to database management systems. If two transactions have been communicated each other, with interleaving kind of operation, then database value which has been written by them will be incorrect. I'll show you an example here. So there is a global value that is, let me say x. So here we have been taken x, not a actually, it is x. X has been taken, it is a global value. So x might be having some kind of value, let us say that is 200. There are two transactions. So process 1 transaction will be, so transaction T1, it is a local machine, it is a separate local machine, and the process 2 having its own transaction, that is transaction T2, it is also local machine. Okay, it is the global area, that is server. For example, it is the server. For example, you could also consider that so these two transactions are agreed for interleaving. These two transactions are agreed for interleaving. How many statements will be interleaved? After two statements of execution of two statements, then interleaving can be gets happen. Then n will be equal to, here also n plus 1, I'm sorry, n will be equal to some 25, for example, 25. Okay. So transaction T1 has been read the value of x right away from here to here. So here to here the value has been read. Yes, it has been fetched the value. Now value of so x will be equal to 200, and after that it has been modified. So modification was gets happened here. Oh, sorry. Modification was gets happened. 200 will be so detected. Let me say updated. 200 minus 25, that is 175. It has not been written onto the server back, because write operation will be after two operations of so transaction T2. After two operations of a transaction T2, it is also here. So therefore interleaving could be gets happened, so that transaction T2 turn here. Transaction T2 will be so read the data from it has been it has been read the data from database to, look at this, data has been read here. So here right now x equal to 200 again, here also 200, here x equal to x plus n. So actually you could consider that n equal to 25, however whatever the value it might be, so it would be updated 225. Now you can observe the instructions. Next instruction, after completion of this, write x. Yes, x has been so written back to the server, should be 175. Okay, of course, read one more value. Okay, it doesn't matter for us. And then after completion of these two operations, then interleaved by transaction T2, now it has been written the value. So here, written the value in the sense to 175 will be so overwritten by 225. Look at this. Process 1's transaction 1, whatever the value it has been written by this process 1 or transaction 1 was lost. This kind of problem is called as lost update problem. This kind of problem is called as the lost update problem. While reading by transaction T2, that reading is called as dirty read or inconsistent read. So here in databases we have to call it as the lost update problem. In operating system it is called as the race condition. In the networks it is called as congestion. Please remember these names. Okay, everything is same. Whatever the operation which is get occurred, everything is same. Because of these reasons, so the operations which have been done by different processes will be overwritten. will be overwritten. Such kind of overwrittens are called as the race conditions. Okay. So this is what about the complete information regarding to race condition. And if you have any questions, please post your questions through WhatsApp, your group WhatsApp. I'd like to answer them. If you do understand this one, that's no problem. If you do not understand, please go through this particular video one more time, because you are it is very important, and it is also asked to you in our final examinations. I'll show you how many times. Okay, you can download. I don't know where it has been put. You can download our so previous question papers from manaresults.co.in. Then you can see how many number of times it has been asked in the previous question papers. And it's also very important. You have to write in terms of databases, in terms of networks, and in terms of operating systems as well. Okay. So thank you for your attendance. Let me take attendance. Don't go away. Let me take the attendance. Don't go away. 22 students have attended today.